The other thing I'll say, well, no, hopefully we'll talk about that. Okay, so the quadratic formula. There's a full statement of the quadratic formula. Which is that your quadratic function y equals at squared plus bt plus c is equal to 0 if t has one of these values. Now, since we're doing a quadratic function in terms of t, I mean, usually when it's stated in terms of x, right? But my variable here is t, so to avoid confusion, we'll say t is this, okay? It's 0 if and only if t equals one of these values, okay? In the case of our function, b is negative 1.8. So we have negative of negative 1.8 plus or minus the square root of 1.8 squared minus 4 times 0.01 times 104. All that divided by 2 times 0.01. Uh-oh. Thought I had a clean board there. I should have one behind it. No, I don't. Oh, man. What are we going to do about this? That's not clean. It got mixed up. Don't want to take time to clean a board. Well, I'm going to stick with small writing here, but we understand that by the distributive law, this is equal to whatever b is divided by 2a plus or minus whatever the square root is divided by 2a, right? In other words, this number here is going to be 1.8 over 0.02 plus or minus the square root of this mess, okay? Now, 1.8 squared is 3.24. 4 times 0.01 times 104 is like 4.16, okay? So that's going to be 0.76 and 0.16. That's going to be negative 0.92, and you can work out these numbers. Okay? So if we have this function, the quadratic formula tells us that y equals 0 if and only if t equals this plus or minus this. Now, what does that tell us about where t equals 0? Well, it tells us that it isn't, because negative 0.92, well, the square root of a negative number is not a real number, is it? It's an imaginary number, and those don't exist in the real plane, okay? So it means there are no zeros. It means that the graph is really above the t-axis, which is pretty much what your graphs do. Okay, what they should be. Now it depends. It's close enough to the t-axis that uncertainties in the data could run it lower than the t-axis, and you would actually have zeros, okay? Now my big point is that this number here is halfway between the zeros, whether the zeros are real or not. Because this number here is what? 90. Okay? It's 90 plus or minus some number that doesn't change, right? Even if it's an imaginary number. So what's halfway, like, if this wasn't an imaginary number, if this was 10, what's halfway between 90 plus 10 and 90 minus 10? Anybody want to tell me? What's halfway between 1 foot to the right of your nose and 1 foot to the left of your nose? Your nose. What's halfway between 90 plus a number and 90 minus the same number? 90. Okay? This number is halfway between the plus, this number plus, and this number minus, right? It doesn't matter whether this number is real or imaginary. It's halfway between. What's halfway between the two zeros of a quadratic? It's an axis of symmetry, right? And the vertex is on the axis of symmetry. So, from this, the vertex is at 90, at t equals 90. Okay? Which means what? It means that our horizontal shift wasn't 100, it's 90. Now from your data, it might look like it's 100, but if this is your model, this says the vertex is actually at 90. Well, what's that do? That changes this number to 90, and it changes this number to 90. 90. Okay? Because that's where the vertex is. Vertex was here. We horizontally shifted it. The vertex is at x equals 90, and that's going to be our h in this transformation. Okay? Then, well, it's really not going to be up 20. How do we find out how far up it is? Well, we just plug 90 in to this. Okay, let's say that's 8100, so that's 81. 90 times 1.8 is 162. 72, negative 72, and 104 is 32. So that should have been 32. If I did the numbers right, and maybe I did, because they were pretty easy numbers. Okay? So now this is really 32. And if you multiply all this out and add it up, it should give you this, if I did it right. And if I didn't, I'm going to ask you to correct it. Okay? You don't have to have all that in your notes. I'll summarize it for you. Although, you know, I'll have pictures up there and everything. Okay? So what I want you to understand from this is just the fact that by using the quadratic formula, even though you probably can't do it on your own, but by using the quadratic formula, we can figure out the x-coordinate of the vertex very easily. It's just going to be this number over this number. And then we can plug that x or t coordinate into our function and find this number, which goes here. Okay? In general, we can do this with any of our functions. General form is this. I didn't get to talk about that, but we'll pick up on it next time, and I'll say a little bit about it in the assignment. Fair enough?